Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Great, so it gives me great pleasure to introduce Tao Xie, who's been a constant and continual collaborator with our team and other teams here in Microsoft. He was previously at North Carolina University and now at the University of Urbana-Champaign in Illinois. And he's pushed and pushed and pushed to get Code Hunt to where it is. And he's still pushing, so that's what he's going to tell us about now.
Great, thank you, Judith. Okay, my talk will be broadly on education. Okay, I think like so far, I mean, quite many of the conversation will be on education effect. But I will try to cover some of other things as well around Code Hunt. So before I get into the details, I would like to raise attention to this, we call it a new field or new term that we coined. Basically, if you look around for many kind of great topics or problems that I mean, this community or I mean, beyond this community have been doing, we are using or developing new software engineering technology like program analysis, software testing techniques to address educational problems, not just like software engineering education, for example, in your undergrad or grad courses in software engineering, right? Broadly in programming, intro programming, even K-12. So typically our research track would consider that kind of work out of scope, right? They would say, okay, go ahead and submit to education conferences like 6CSE and CSE and T or education check of software engineering like ICSE. But we really are lacking some of the important value for showcasing great research being done in using or adapting or developing new software engineering technologies to help education. Okay? If you see around, for many other fields, for example, PLDI, SIGPlan community, or data mining, triple AI, they are all open for the different kind of problems. Right? I think software engineering community has been kind of a narrow-minded in terms of that, right? I mean, we really want to push that to see that such kind of a research results would have a place in research track of major software engineering venues, okay? So, I mean, if you talk about the definition, but basically it's talking about in the solution space, it's quite related to software engineering, it's software engineering, but the problem we are assisting would be education. Okay. Traditionally, the software engineering researcher would consider, oh, this kind of problem are not helping engineer, are not related to code. I mean, that's out of scope, and that's kind of an argument that some of the colleagues in our community would be making, and we think that's too narrow-minded. That would hurt the health or the growth of our community. So, as a continuation of this great workshop, I mean, like today is the last day of the 2 days workshop, and we'd like to think, what's next, right? I think the last section, I mean, the panel discussion would talk about that. So here I just would like to propose something that would be concrete, I mean, for later discussion. Basically, could we have a workshop as a beginning point, right? I mean, here's a kind of proposed workshop named like Code Hunt Workshop on Educational Software Engineering. I think as a starting point, we shouldn't just narrow the scope to be just exactly work being done around Code Hunt, right? Because we are using Code Hunt as an excellent platform to engage researchers to do more work in this space, right? Like the earlier programming system is not Code Hunt. If you do some work upon it, that would be within the scope of this community for showcasing the accomplishment and engaging more researchers to jump in to allow us to build a better future in this very important problem. So that kind of inspiration was from like International Spin workshop on model checking on software. For those working on verification, you know, right? I mean, like not just like the work being done around spin system would be within the scope. It's just in general, model checking software would be within the scope. But of course, we are open for like suggestion and discussion to see whether that's a best name to start with, or we have some other name. And in terms of venues, I mean, one possible idea is that this year's ISTA which will be in Baltimore. And next year we have XE in Austin. I mean, I think quite many researchers in this domain would be in like North America. It's good to start from North American venues. Okay, but in the future we expand to other like continents. Okay, so get into code hunt. I mean, we talk about the gaming, engaging, fun aspects, right? I mean, the key, like what Judith mentioned in the end in the slide, the reverse engineering aspects, it would really make a code hunt unique, or more particularly the coding duels gaming types. So basically, we said you have some exploration, guessing, discovery, I mean, related to the previous talk, like autonomy. Basically, you have autonomy when you are playing coding duels, right? Basically, you add an if statement in your plain code. You actually force pegs to really allow you to generate output specifically for that input data, right? So although the interface does not have explicit input box to say, okay, show me the input for this particular output for this input, right? But you could do that with some particular kind of like manipulation of the code. So basically you could view it, it's like, it's an elephant. I mean, this is kind of like a well-known story. It's like, I mean, blind people trying to get what it is, right? I mean, they touch on different places of the big elephant and then made a guess, right? I mean, think about the data being generated by pegs would be like different portion of the elephant, right? It's just like, you want to like have fewer touch in order to really guess, oh, that's an elephant. Right, so that's kind of like an analogy I would like to make in terms of like the engaging and gaming fun aspect. So I think like some of you probably already heard about some of these quotes that we made in like different presentations on the previous coding duels at Peg for Fun. Here are some of the quotes. I mean, I just read some of them. Like, I used to love the first-person shooters. I mean, the type of game, and the satisfaction of blowing away a whole team of newbies playing Rainbow Six. But this is far more fun. It's referring like playing coding duels. I mean, you may say, this person is too nerdy, right? I mean, like, you would like to play this kind of first shooter game. But the second one is talking about like, seems to be full-time employees in a company. They're saying that, oh, I'm afraid I have to constrain myself to spend just an hour or so a day on this really exciting stuff. I really start with work, right? Or maybe student with a lot of coursework, right? We don't know. And the last one is referring to the educational effects, I mean, which I will get more into the details based on our experiences. It's just saying that it really got me excited. This part that got me most is about spreading interest in teaching computer science. I do think this is really great for teaching and learning. Okay. But hopefully, all of us would be convinced by this kind of excitement and the fun part, along with the learning and teaching effects. So the second thing is kind of related to the first point. It's like the gaming, the fun part, but you really want to sustain people's energy, the enjoyment, right? I mean, I think that's related to like one of the factors being mentioned in previous talk. The competence, right? You need to feel you are good, right? You could make progress. So, like here's a kind of snapshot of the XE 2011 Coding Duel contest in terms of like the outcomes. You already know the dashboard. Basically, green will indicate that you solved the games, and the red will indicate you failed, you couldn't. The number will indicate how many times you tried. And often time when I give talks, I will ask people like, for this student, like 147 times trying this difficult problem and finally got it. Would you like to hire this one if like you are employers, right? And I mean, with the limited data you have, because this really show your persistence, really not giving up, right? And then finally got it, right? But of course, we had quite some statistics based on our course or this context. People tried for so many times, did not get it. Right? But of course, we cannot just look at the number. That's why we need to have analytics to look at the details. Like exactly why this student could they get it? Could we infer some of the problem-solving patterns, like undesirable, kind of like or just shooting around without systematic exploration? Right? Based on the course that we taught, we did indeed found out like quite some kind of like pitfalls or weaknesses in terms of thinking patterns. Okay, so like when I give talks in this topic, Coding Duels, over the time I would say, okay, so far our analytics may not be up to speed, but for those parents who have kids, they could spend time in walking through, replay the problem-solving process of their children in order to understand what other things they could help improve their kids' thinking. Okay, so the point here, I'm trying to put these statistics aside. I attended this contest as well. That's the kind of last snapshot of the code that I wrote. Like basically, I kind of like really get like frustrated to some extent, and then really awkward. I really couldn't figure out the pattern. Right? What is going on there? Right? I mean, like I tried more and more data points, still have no clear clues. Right? Maybe I mean some of you already identify what this functionality, the hidden functionality would be about. But as you can see, like in order to engage people, we really need what we already heard about, like hint generation, progress indication, and different kind of techniques to allow us to really engage people, right? And in context, exposing some hints may not be that desirable if you really talk about real context competing with each other. But in a learning, educational setting, it's very important to have that in place, or like outreach to really allow kids to really gain more knowledge and with this great platform. So, as I said earlier, we'll get into the teaching learning part, and hopefully I could share some experience with you, and then we have some discussion later on. And finally, I will just briefly show some of my experiences in terms of integrating Kohan or like videos, other teaching materials using Office Mix. Basically, you could record your lectures together with exercises, intermix with your lecturing. So that's another great aspect for you to think about in terms of integration into your teaching. Now let's get to the first part of what I'm going to talk about, the progress indication. Like earlier, William already talked about using like a model counting the solutions that would satisfy certain paths or path condition. And here I'm going to share with you some of the very simple techniques, not necessarily like could reach that kind of accuracy as what William discussed, but have some initial starting points. So here's a concrete student solutions for certain Coding Duel from Pick for Fun. I mean, these are the real snapshots. As you can see, the name of the puzzle is it's fancy year. Okay, so it's just like you have to guess what the functionality is about. But on the left-hand side, a student or a player actually figure it out by giving some tries and then write this more kind of an extensible, elegant kind of a code, right? Just like doing some computation. But actually, because this is a limited number of the scope, the data range, you could enumerate every single one, okay, by watching what PACS will produce. So that's also a correct solution. Right? If you use some of these kind of edit distance, like earlier, like automatic grading techniques, it wouldn't work well in these settings, right? But of course, in other settings, especially when you enumerate kind of like comprehensive strategies, then using this kind of a static edit distances would work well. But the key point here is to motivate the needs of both syntactic edit distances and behavioral similarities or distances. So another interesting point, I think, so far this topic was not raised, is about behavioral subsumption. Okay. It's not talking about, oh, I'm closer, right? Maybe I'm the same, right? For example, okay, for percentage-wise, 10% of inputs in the input domain, I have them correct. Another solution, also 10%. But they may be complementary, right? Maybe this 10% would not overlap with the 10%. So you cannot just say, oh, these two are the same, right? So that's why we talk about subsumption. As you could see easily, the top is the secret program. The left-hand side near the button, that would be one of the student solution. Right-hand side would be another one. All the same student making progress. As you could see, the right-hand side would subsume the left-hand side because the input domains, the passive input domains on the right-hand side would subsume the passive input domain on the left-hand side. Okay, so I think this concept would be important to incorporate when you give feedback in terms of progress. So here we have some prototypes like in terms of like the techniques. Actually, these techniques are very simple. Like with PECs, we could very quickly prototype these ideas. The first one is the basic one, not based on PECs. Basically, you randomly generate some test inputs with the domain, and then you see how high percentage of these inputs would pass. Okay. So the basic idea here is like if you talk about in general, we are using the number of the passing paths among all the paths that you have tried. Okay? So, and in addition, not only just compare the number, we would also be able to look at exactly which particular path actually would actually pass for both versions, if you're talking about comparing these two versions. Second one, we call it a single program symbolic execution. The idea is to use the reference, the secret code. We just use PECs, explore the path up until the bound, and then we just use the test input, run on a student solution, and then see how high percentage of the paths would pass. Okay? The good thing about the second technique is that you are not that sensitive to the student solution. When you are judging something in a relatively like objective way, you don't want to be influenced by what the student solution would be saying. Right? Of course, when you judge whether it's equivalent or not, you need to take that into account. The third one is exactly using the checking engine of PECs for Kohang. Basically, you pair them up, and then you just see like how high percentage of the paths generated by PECs would pass for these kind of pair programs, the secret code and the student code. Okay. The advantage of these techniques would be like, especially for the last one, it's direct piggyback to what PECs is already doing for checking the equivalence between the secret code and the student solution. Okay, so then you don't need to have actual costs there, right? Of course, the open question is that good enough? Is that like could we do better with actual costs, right? I think these are the open questions that we would like to investigate, especially like Williams model counting solutions to further help us to push the accuracy or the goodness of the metrics. So here I'm not going to share with some statistics. I'm just share you some examples on cases from PEC for Fun platforms, what technique would work better, right? So this is an example where like the pair symbolic execution, the last one, the third one, would work, but the symbolic, like a random sampling and the single program symbolic execution wouldn't work that well. As you could see, naturally, if you just randomly generate a bunch of inputs, you may not hit the branch that the submission tool would include, right? Similarly, if you just use the code for the secret code for test generation, you may not hit that inputs that you would like to use. So for such situations, as you can see, the pair symbolic execution, which is the current checking engine, would give us the better result in contrast to the first two. Here's another example, like on single program, single symbolic execution and pair symbolic execution would produce desirable metric values. As you can see, this kind of non-trivial sophisticated stuff for the secret code, and then using symbolic execution either on the original version, the secret code, or you pair them up, could allow you to get desirable metrics to compare the differences. Okay, so next I'm going to move on to talk about coding duels for teaching and learning and share with you some of the experiences, particularly from like how to construct coding duels for a particular lecture topic or knowledge points that you would like your students to learn. So previously, not previously, I think PEC for Fun still has this kind of a teaching platform. Basically, you could go in and create your course or course page, and basically course page would include those materials that you want to teach students. And in such course page, you could also embed coding duels to allow your student to do exercises besides looking at those materials that you want a student to learn. The feature is very nice, and then there the feature of allowing teacher to see every single step of students' solutions would be also there. Basically, all the intermediate versions a student produce when playing the Coding Duel would be visible and viewable by teachers. So we talk about like, oh, like it's fun, it's guessing, but what do we learn from there in terms of general skills? Okay. If you look at a little bit deeper, induction is one of the skills that such game would allow you to train students with, right? Because students look at concrete data points. They need to generalize and see, oh, what kind of code, because it's more like data generator. It's just like you couldn't know what the generator is about, but you just use the data, try to reverse engineer back to the data generator, right? So that's one aspect. Naturally, problem solving and debugging is part of the whole process, right? And that could be in the first phase of reverse engineer the functionality, could be in the second phase after you know what the functionalities you want, then how really implement the code to really realize that functionality correctly, right? So initially you may not have the correct version, then the process will be debugging. Program understanding and programming, and we did not talk about program understanding so far, okay? But Coding Duels could be very flexible to allow you to put in a bunch of code for people to understand what it's doing. Okay, I don't know how many of you actually in your like college, I mean, learn about one specific type of the exercises or problem. Basically, when I was in my undergrad, the one common type of the problems would be like they give you a piece of code, they take some pieces out, like one line out, one expression out, and then basically they may just give you high level like a description saying that this is sorting. I really don't tell you what kind of sorting is about, right? You have to really figure it out and then fill in the blank, right? So with Coding Duel, you could easily do that, right? You just write a big chunk of code and then say, okay, please fill in the next line, right? Or please fill in this missing expression, okay? For some of the Coding Duel, I'm going to show you actually have that nature, right? I mean, so far, we haven't really experienced that with our discussion. Testing. Testing is not directly supported with like Coding Duels, but I'm going to show you kind of somewhat clever way of using the Coding Duel format, but still test students' testing skills, particularly on writing test oracles, okay? Or primary unit tests, which has been supported by PEX since 2005, okay, for that concept. And specification writing, and somewhat related to testing, basically how to write code contracts, right? PEX for fun supports code contracts like code hunt. I don't know whether code hunt supports code contract. No, okay, not yet. So, but basically, when you use a code contract support, you could also train students in terms of specification writing, okay? Now, let me show you some concrete Coding Duels that I created for a graduate software engineering course, okay? So, I mean, I would say further higher up, it will be more difficult for you to create this Coding Duel because a common understanding would say, oh yeah, this is for intro programming, right? So I show you some example how you could create sophisticated Coding Duels to train student skills, okay? So you could access all the Coding Duels and materials from this URL. But let me just briefly talk about the benefits of using Coding Duels in your class teaching, right? First thing, we solve a lot of headaches of automatic grading, right? I mean, or like grading, right? Both the TAs and I are very happy, right? I mean, we just really reduce a lot of workload, right? But again, I mean, I think there's more research in terms of like, if student couldn't fully solve a Coding Duel, shall we give partial credit? I think the automatic grading would come into the picture to really give people partial grade, credits. The second effect, I think that would not be available in a traditional teaching environment is like you see this kind of a student progress or intermediate solution along the way. Right? So for example, after I distributed certain exercise, then I saw students trying so hard by overthinking the difficulty of the problem. Right? Then I would just in my lecture or in mailing list, I would just say, okay, these problems are not that difficult. Don't think that hard, right? And so you, rather than after student already finished the challenge, I mean the pain, and then finish submitting it, and then you tell students that's not. And sometimes maybe due to undesirable design of your problems, right? You would like to really, alleviate the issue early enough rather than, oops, that problem was not good enough, right? After the student already submitted their solution, okay? Also, a little bit fun experiences like when you instill this kind of guessing aspect into this kind of platform in your exercise, you could allow students to enjoy that kind of fun aspect that we discussed very early on in this talk. Now let's look at some of the coding duels. So here's the most complicated coding duel along the line of asking students to read natural language description about code contracts. Basically, we extracted these sentences from API documents, like a Java API document or NSDN, for extracting those real-world sentences for capturing like constraints or properties. This is one, very sophisticated, as you could see. Quite a lot of text there. I'm not going to walk through. But keep in mind, we did not actually remove anything from the original text, as you could see here, indicating the type 2 for string max to 55 characters, 3 for text basic indicate the type. For the existing code contract, or no matter what kind of language you use, you don't have a mechanism really to specify that kind of dependent constraints, okay? So we intentionally not to remove that, but let students to use our check-in engine to figure out what they really need to put in, which means that not exactly they need to finish formalizing everything there because they have to rely the check-in engine to see what's going on. So let me just expose to you the solutions, what the solution would be like. The student must write this kind of a constraint. Of course, not necessarily this way, right? But as long as the semantics would match this way. As you could see, the last two require students to really formulate sophisticated regular expressions. Okay, that's not a trivial task if you look at the statistic of how many times they try. Okay, so in this situation, a little bit guessing there. As you can see, some of stuff actually are not formalizable, but we did not tell students. They have to use this a little bit guessing to really figure out what things they actually want to formalize, what things they wouldn't, because it's not formalizable by nature. Okay. So testing. Some of you will say, oh yes, we use PEX. It's a great text generation engine, but all the testing had been done by PEX, not by the players, right? How do you really train students in terms of testing, right? So here is what we did, okay? Basically, for those who are familiar with primary unit tests, basically we asked students to write primary unit tests, okay? So for those who are not familiar with the term, but basically, traditionally, unit tests wouldn't have parameters, okay? But now, primary unit test, you have parameters. You could pass input through that parameters for your unit test, but you need to have one somewhere. You get the test data, right? Then PEX would supply good test data to re-exercise the different behavior that you specify in your unit test, in your primary unit test. So that's what a primary unit test would look like. As you can see, we turn this primary unit test to be a puzzle. Basically, to be that particular code you want to fill in. Okay? And we intentionally leave some lines of code out for this complete primary unit test. This test would be for testing a bounded stack. Okay? Or basically, a stack can allow up to a certain number of the elements. Okay? So we have this kind of setup. For example, like initially, we set up a stack with certain elements. Why we do that? Because you don't have parameter. Non-primitive parameters to be allowed in the test. The parameter, the argument of the primary unit test. But in general, you could write that, right? But then that's why we put some setup there, hard code some way for constructing good enough. Stack object, and then we cache some value for you to later to use in the assertions. Okay. So here, we already put some assertions to check the behavior. Okay? But we don't really tell you what method call, what method under test you invoke. So there's a guessing part there. So they have to observe what's going on in terms of, especially, this is something that I have to put in order to really leverage Coding Duel to do what we want to do. Basically, we turn observer methods return values into a string. It's kind of a little bit clever way for formulating the problem, because then we could make sure that whatever we reach here with the right method call in the middle, we had the same behavior as the one behind the scene for the secret primary unit test. Okay, so let me disclose the solution. Basic solution is saying that, okay, first I want to make sure the element before I push this element into stack is not in the stack already. By the way, I want to revise a little bit my discussion. This is about bounded unique stack, which means that if you have duplicate elements being pushed to the stack, you still have the same set of elements, but you switch the element to the original. You basically remove the original duplicate element, you push the new element, duplicate element on top. Okay, so that's a behavior. That's why we need to have that in order to really test certain behavior. When this element already there, then you return assumption violation. So again, that's kind of like careful setup to allow you to leverage the output checking of the two methods, the secret code and the player code. And then we want to make sure that the number of the elements in the stack is not already full, right? Not already reaching your upper bound, and then finally you push. And finally, you could have this behavior being checked correctly, okay? So a little bit sophisticated, but that's still usable for you to really train students in terms of specifying the behavior or test code in primary unit tests. Design pattern, I'm not going to spend more time on it. I think we are reaching soon to the end of this presentation. But the key point here I want to say is that you could even construct a coding duel, not just a method. For this coding duel, actually I had multiple classes. Okay, as you can see, I mean, for certain design pattern, you need multiple classes to be in the picture. But we still have this puzzle method to be more like the kind of a test driver, like you want to test like a bunch of the classes behavior, right? And being constructive with certain design pattern. So here you basically you have this more like a test code, and what the student would need to do is to fill in for specific class, specific method. We give them comments, say fill in code there, okay? Then we give them all these other kind of like a component classes to allow them to really assemble things. Okay. So the solution is like this. Basically, that's the golden solution. We need to carefully construct the sequence of method calls to allow them to have unique behaviors. Okay. One point I want to emphasize is that actually this coding duel is not quite desirable. I mean, I discovered that only after the fact by looking at statistics of how students would try this coding duel. Okay. The issue is that when you figure out what this design pattern is about, by the way, like we don't tell students what this design pattern is about for this coding duel. They need to discover what design pattern is about, and then they need to assemble these lines of code. Okay. But in order to assemble the right sequence of code, a lot of students have to rely on more like exhaustive search. Try all different kinds of combination and then click the button. And the result being displayed to the players may not be that informative to allow them to relate and have a little bit thinking. In the end, it turned out to be just more like exhaustive search. So in that sense, it's not quite desirable, because it's really not exploiting students' intelligence or thinking, right? Even like you have different students who would like to speed up the efficient exploration process. Okay, so then the third one actually is better. I'm not going to get into it, but students have there. I think again it's kind of on two extremes. For that, as long as students realize that's the design pattern, they could just one time try and then finish the duel, right? Then you kind of lack of a little bit guessing exploration sense. So the point here I'm making is that it's not a trivial process for you to really immediately design certain high quality desirable coding duel without some iterations. Okay, so I would like to wrap up soon. So Judith, how many more minutes do I have?
Oh. Two.
2. Okay, good. I think I could wrap it up. So I want to mention one thing is that like coding duels, I mean the format of the gaming type coding duels would be very powerful. Okay, not just like return X, return 0. Okay, I already mentioned some of the program understanding kind of coding duels. I don't know how many of you actually heard about like a person's puzzle. Anyone? No? Okay. So basically, it's kind of like a very simple puzzles about code. Basically, your goal of finishing the puzzle is to move around statements. Okay? They just shuffle the statement, make it the wrong order. Okay? Then your goal is to move back to the original order. Right? Actually, for some of the earlier coding tools that I created for like intro programming, actually I intentionally try to do this and ask students like, please reorder the statement that are given, right? And don't modify anything more, right? So that's kind of like a puzzle already exists and people already use that. And basically in Coding Duel, you already have that support, right? You could write this kind of puzzle easily, right? I mean, when you don't need to type code, you just move things around. I mean, I put the like HoloLens here, like, I mean, maybe in virtual reality, you just move a chunk of code. I mean, this and that, right? I mean, have a little bit virtual reality there. And so that's kind of like, could be fun to try, okay, for specific restricted form of the coding tool. Okay, I'm not going to show you more about the Office mixer that I make, but you feel free to really look at them. Here, for this like a presentation, I did not include like any of these coding duels exercises. Actually, I mean, coding duel exercise could be included in your presentation. Personally, when I use Office Mix in making a video, I mean, I like it very much in terms of like my personnel would be a little bit cautious, right? When I feel, oh, I did not say it in the perfect way, or in the way that I'm satisfied, I could just replay and record only for the slides. Okay, I mean, in other recording platform, then you have to redo it, or like, I mean, it's a little bit sophisticated. But this is very convenient for you to do kind of like a micro kind of editing to really polish your slides and your video recording. Okay. With that, I think I will wrap up the presentation. Particularly, I think it's an exciting platform. Of course, there's more work to be done. I think like many of you have some great ideas, and then like it will be a great future for fully exploiting the power of this platform for education and learning. Okay, I think I could take some questions if anyone have questions. Right, thank you. There's a lot of contents, I know.
So I'm not sure if it was clear to everybody, Tao, about whether what you did in PEX can work in Code Hunt.
You mean PEX for Fun, or?
PEX for Fun.
Okay. So, I mean, one very important feature, I mean, at least, I mean, I'm pushing hard, right? It's just for an educator. Personally, when I use these coding tools in my teaching, inspecting the plain histories, that's very critical for educators' point of view.
And you have that in PEX for Fun?
Yes.
Why? Why is it in PEX for Fun and not in Code Hunt, Billy?
There are some missing features.
Ah. So it wasn't added subsequently to PEX for Fun.
PEX for Fun has a lot of things we added for Tao.
Yeah, I'm more like being the subject for experiments, I mean, right? So.
Some of these didn't make it back in.
Right.
There's like if you look at the bottom of PEX for Fun, all your actions are recorded in the page itself. You can copy paste that. I don't know if your students still use that.
Mm-hmm. Right. Because then they have to manually copy one try into a file, right? And then like next time, I think that would work, but I mean, they could just skip some stuff, I think, right?
Yeah. So you mentioned you created a grad course on PEX for Fun. So I was wondering, how did you use it in classroom? Because here, students will keep being able to submit it multiple times until they get it right. So how did you check students in terms of grading or anything, because everybody would get perfect marks if everybody can get it right using the system?
Not necessary, right? I mean, but indeed, the exercises would be created in a way such that most students would get it, right? But of course, if you really want to differentiate, I mean, because this is not final exam, okay? This is more like homework assignments, right? So we said, I think the major emphasis would be on learning, right? Finally, they get it. Oh, this process, yes, they may try many times, but in the end, they get it, right? I mean, for example, for some of the, very interesting, if you look at the plain history, I mean, like, that's why I'm a big supporter or fan in terms of getting access from the teacher point of view. For example, for code contract, right? For the requirements, exercise, some students just did not know how to, did not realize they need to use code contract API to invoke that, right? They did not read the text, the materials, right? They did not follow things, like many of us, don't read manuals when we try to operate certain whatever, utilities. So then they finally give several times a try. They feel, oh, I need to use code contract API. And then they put it in, right? So you basically, you observe these kind of struggles they went through. Indeed, such students may need more attempts, but the learning effect would be accomplished if you talk about education purpose, right? So that's my philosophy. But if you use it for final exam or exam, then there we want to have similar kind of a nature as a contest, right? You want to really differentiate top performing student and reward that with good grades, right? And then not that performing student, you may not give that higher grade as others, right? So that's my philosophy there, yeah.
Welcome to Alfred Thompson, who's our representative from the K-12 school community. And he's going to tell us about his experiences with Code Hunt in K-12. Thanks, Alfred.
Thank you. The nice thing about teaching in K-12 is I don't have to publish, among other things. So my talk will be a little bit different. Basically, sort of by way of introduction, so you know where I'm coming from. I'm one of those people who keeps moving back and forth between education and industry. I started out as a software developer, did everything from applications, programming, operating system development. When the company I was working for kind of went away, I went into teaching while I decided what to do next. 9 years later, I went back to industry, worked for Microsoft in the academic relations group. And then about 2 years ago, I dropped back into education, where I'm having a really good time, trying to implement all the things that I learned in 9 years of dealing with educators working for Microsoft. So my environment, just to give you some background, I teach at a private Catholic college preparatory school. On a bad year, we send 98% of our graduates to a 4-year college. Again, that's a bad year. My main programming course that I'm teaching now, I teach several courses, but I'm teaching a course called Honors Programming, which is, it's honors because it's hard to get students to take electives in a college prep school if they can't get weighted credit for it. Don't tell my administration that that's why it's an honors course, please. So, in fact, most of my students have very little, if any, programming experience, which, as you know, teaching beginners can be very difficult. You're teaching a way of thinking, you're teaching a language syntax, you're teaching different problem solving, and you're trying to do it all at once. You know, I mean, it's really building the airplane while it's in flight. Right now, I have mostly sophomores and juniors, so 14 to 16-year-old students. They're kind of used to having things spelled out for them, which doesn't work in programming. So we're teaching it in C#, in large part because I like C#. And it allows us to do interesting GUI programs. And trust me, high school kids, they want to see the pictures. They want to see things in color. They want to see things move. Getting them to sit still for white ASCII text on a background is a non-starter and just very frustrating. I'm using Code Hunt in my class. We have another teacher who's teaching AP. I've got him playing Code Hunt quite a bit and trying to convince him to use it with his students, starting to make some progress there for some of the same reasons that I'm using it. Which brings you to the question, why did I decide to use Code Hunt? Towards the last third of last semester, I realized I was having some serious problems with my students. They had very poor problem-solving skills. They just had no idea about turning a problem into code, how to put it together. They were just horrible about it. And worse still, they had no concept of test data. You could give students a simple program that you do instead of a low world, a temperature conversion program, Fahrenheit to Celsius, Celsius to Fahrenheit. And then you ask them to test it. And they'll type in 17, and an answer will come, and I'll say, is that right? They'd say, I have no idea. Then why did you use it? I don't know, it was a number. I said, you know, are there some values you know? Well, I don't know, well, think about it, you know? You know, test it with 0, you know, Celsius. Test it with 100 Celsius. Test it with minus 40 either. I mean, you know, these are things you know. So I decided that what I needed was for them to practice. They needed to practice problem solving. They needed to get a better understanding of how to use test data. You know, how does it make sense? How does it fit into what you're doing? So what I wanted, right, very simple. I wanted self-grading, self-testing exercises because I wanted them to do a lot and I didn't want to grade and test each one. That was a non-starter. So I wanted something that would tell them what they were right, what they were wrong. I also wanted something students could use from home. You know, at the university level, typically my experience has been students have great laptops, they install all the software, or they have easy access through virtual machines through the campus network. My students do have good computers at home. They do have good network connections, but they don't always have the software. While I can get them Visual Studio for free, I didn't really want to deal with the administrative overhead of making sure they installed it right and got it set up right. Some of them do, make no mistake, some of them do, but I didn't want to put that burden, especially on the weaker students. And then, of course, I needed an environment that appealed to students. Making high school students do things is like pushing string. They sort of define passive aggression. So if something appealed to students and that they wanted to do it, that I felt would be a lot better. So things that I knew, students will work for points. Actually, you can get students to, in high school even, to do things for stickers. Candy works great. Stickers, points, pretzels. They'll move heaven and earth for a marshmallow. Just, you know, but points are great. They also, well, at least the boys, some girls, but mostly the boys, they like to compete. They want to compete with each other. They want to compete with their peers. When my students found out that the other computer science teacher was working his way through the default zone on Code Hunt every day, this is how far I am. How far is Mr. I? They love to compete. The other thing that I've known for a while, and I've seen research on this, is that most students don't get as upset at the computer when it tells them they're wrong as they do when a person tells them they're wrong. They're not intimidated by that. If the computer says, you goofed, they say, oh, fine, I'll try something else. I tell them they're wrong, and they'll sulk the rest of the period. So turns out that Code Hunt sort of hits that sweet spot. So I use Code Hunt several ways. I started initially last semester, I teach one semester courses. I threw the kids into the open zone, the default zone. They liked it. It did some interesting things. And quite frankly, their response to that motivated me to do more. The next thing I started doing was putting Code Hunt puzzles in Office mixes. For those of you who haven't seen Office Mix, it lets you record from your PowerPoint. The recordings can also include quiz questions, true, false, multiple choice, the whole bit. And among other things, you can include Code Hunt puzzles. And that turned out to be a pretty interesting thing, and I'll talk more about that. Then I got really motivated, and I built my own custom sector or zone or whatever it's called. I got to get the terminology in my head. I'm sorry. I'm going to make a chart, and I'm going to put it up on my computer. But I did that for a bunch of reasons, which I'll elaborate on. So the open zone had some real positives for me, and it had a few negatives. Some of the negatives, it looks like maybe better with the new model, with the new zones that are coming out. Positives, very challenging. Really challenged the kids. They really worked hard. They wanted to work hard, and they did some good things. The scores, as I said earlier, were motivators. Kids would go back and try and get the maximum points, and they discuss amongst themselves. All right, how did you get all 3 boxes? I've got 1 box or 2 box. And that's, of course, a basic part of Code Hunt. And there's the wider competition, that they could see other people, they could compete with their teachers. They had some sort of beyond the classroom kind of feeling of competition. Well, the negatives, again, very challenging. For absolute beginners, some of those puzzles got a little bit painful. Actually, for their teacher, 1 or 2 of them got very painful. This caused some of them to search for solutions on the internet. And the problem with that, of course, is it's hard to tell who's solving them themselves. What did they learn? Did they understand the solution? So that kind of was one of the reasons why I wanted something of a private box that I could send the kids to. So with Office Mix, and actually this is just a page from Office Mix, it shows a couple of the mixes that I went for. It turns out that there are a number of other people who have done computer science programming related mixes that include Code Hunt puzzles. I need to go through and load links to all of them into my learning management system. My feeling with that is that I tend to have a certain way of presenting a topic. I think it works absolutely great. It's crystal clear to me and makes total sense to me. Apparently, I'm gradually finding out not everybody sees things the same way I do. Go figure. So I'm looking forward to providing students access to more explanations of these important topics. So with Office Mix, initially my thought was that these were going to be great for catching up after an absence. If the student misses a lecture, you wind up spending, at the high school level, you can lose a whole period or so just trying to catch one person up. And my feeling was that putting the mix up along with PowerPoint and other links, they could use that to help catch up. I don't run a complete flipped environment. I know that's a very popular thing where you have the lecture and then you come in and discuss it. I'm trying to move a little bit more to that, but I'm not ready to go, all the way. So I have been asking students recently to look at some of these mixes as a preview for the topic. Specifically, I knew I was coming away for these couple of days. Turns out I needn't have worried. We haven't had school yesterday or today. Apparently 5 feet of snow and they'll close school. Go figure. And I find that about half of my students, if I ask them to do anything at home, about half of them will do it. I'm apparently not scary enough. We have teachers whose students will do everything they tell them to do because the students are absolutely terrified of them. I just haven't got that skill. But I am finding that the students who do view the previews come to class much better prepared for discussion, and I'm hoping to expand that use. The big win for me is the review. I had my students at the end of last semester. I suggested that they all review the mixes, do the puzzles, and the day of the exam, one of my female students came in and said, I watched that video and it clicked. I understand it now. I don't know what I said differently. Maybe it's because she stopped it and backed it up, but that turned out to be very helpful to a number of students. So that I'm finding encouraging, and I'm going to continue to make these mixes. I don't believe they're adequate by themselves. To get students to watch them, you have to keep them short. And I do. They're all 5 to 10 minutes long. Again, that's the attention span in high school. It's only slightly longer for faculty, I found. So anyway, I built a custom sector. This is a screenshot of it. Initially, I've got 4 sections related to basically the first few main topics that I'm dealing with. Basics, that's assignment statements, converting, the math that they're used to thinking of to the math that a computer wants, which is a little bit different and a source for confusion for beginners. Decisions, which we actually just covered. I did one quick lecture on decisions. Strings and then loops. I'm going to do some things for arrays and something else, over time. Fortunately, I learned yesterday, there we go. Yeah, this is why I like the custom sector. One is it's easily adapted to my curriculum topics, all right? I think most first programming courses tend to go in a fairly similar manner, but this allows me to do it in my sequence, using my kinds of examples, and hopefully that'll build on the lectures. I also wanted to level it. I didn't want things to be too hard. My goal is for them to have practice. My hope for them is to have some success, because students who have success tend to be encouraged to keep trying. If kids get too discouraged, then they give up very easily. So I wanted to keep those levels, and I've got an example up ahead of one of the things I did to make something easy. And then again, they can build on the examples that I use in class, on the types of projects that I demo and whatnot, and they'll see familiar patterns, familiarity, repetition. I'm hoping they'll learn these patterns and be able to recognize them when they see them again. All right, this is one of the puzzles, and I deliberately did something here. You'll notice that x is 0 has an expected result of 32, and x of 100 has an expected answer of 212. Yeah, what could that be? And there's a clue up here, cold. The students have already done, well, this particular semester, they've already done a temperature conversion program. So my hope is that they'll see that and they'll start to think, oh, well, this is good test data. This makes sense to me. I don't do this for all of them, but, for occasionally, I want to do that.
So just to emphasize, if you go back,
Yeah.
for everyone else, this is Code Hunt running in Office Mix.
No, this one is not. This is just as I send them a link to their own thing. I do have samples of it running in Mix, but I didn't do that for this talk. I thought about it, but unfortunately I thought about it 20 minutes ago and decided that all right. I did add this slide 10 minutes ago, but
As a value?
I was kind of surprised to see not a number. What I'm hoping at this point, because I haven't seen the students in a couple of days, is I'm hoping that when I get back, somebody will ask me what NaN means. And in fact, one of the things that I am hoping to come from these is some conversation. Lectures, are boring. If I can get students to talk about them, and we're going to specifically talk about some of the questions, my first day back. And yesterday, when my school has canceled school because of snow, usually, we make assignments online through our learning management system and ask students to do that. And we have permission from the state if I think 75% of the students do the work, which has an assessment piece, we can count it as a real school day so we don't have to extend the year. The assignment my students had yesterday was to tell me the last of the Code Hunt puzzles that they had worked on and what problems they were having with it, what's keeping them from solving it. And I found some interesting things in that, which will start conversation. If I had a good look at data on what things they'd tried, that would be very interesting and valuable. But since I don't have that, I will at least ask them and talk to them. Which actually naturally brings me to this slide. This is the zone dashboard for my class right now. I don't know who some of these names are. That's what happens when you let students choose their own names. This outlier here is me. I don't know why the score is that way. It probably has something to do with the fact that I was playing with the zone a lot. Now, this column right here represents the start of the decisions section, which, as I said, we've had one brief lecture on. So what I'm seeing there is not quite half of the students have completed several of them. Most of the class is having serious problems with it. Now, this is interesting because for all of you, this is phenomenally easy, and I would be surprised if any of you took more than 2 or 3 tries. The problem for my students is that using the modulus operator doesn't come as quickly to mind as it does to most of us. All right? All of this is asking is if the number is even, show heads. If it's odd, show tails. That's it. One very simple if statement. Some of the kids figured it out in a few sessions. Some of them, one's got 55 tries. He and I need to have a serious talk. when I look at this, as I mentioned at the very beginning, some of my students have had no previous programming experience or very, very little, and some have had actually considerable. Now here's the interesting piece. Most of these students have had more than a little programming experience, except for the two girls. All right, 2 of the top 4 progressions here are girls who have had almost no previous programming experience, which is really encouraging to me. And in fact, I'll talk a little bit more about that. But kids are definitely trying. They keep trying. We're going to talk about these things. We're going to talk more about, I actually didn't anticipate sending them on to these projects or these puzzles until we talked a little bit more about decision structures. So, you know, I'm not as worried as I might have been. These kids down here are still doing the basic stuff. We need to talk. But I really believe that this is going to be a useful tool for me to identify students who are struggling with understanding the problem solving. It'll give me a chance to talk to them about, you know, how do you look at the data? What does it mean? What are the relationships between items in the test data? And that's what I want. I need to know where kids are struggling so that I can help them. I do. I have to talk to her about that. Again, yeah, Anastasia, I don't know why there are 2. I think she's signed in with 2 different logins. And I'm going to ask her to pick one and stick with it. That's going to affect the scoring, yeah. But, you know, she's clearly a very bright young lady.
Be the winner.
Yeah. Yeah, she's got. So a couple of observations, and I haven't really tried to do things in the totally scientific method because I'm really still learning how to build the puzzles, and I'm really still learning how to incorporate things. I am planning on asking a series of questions in my end of course survey about the use of Code Hunt. I'm going to ask them, you know, was it helpful? Was it distracting? You know, did it increase their interest, decrease their interest, and things like that? Again, it's a small n value, so it'll be still observational and anecdotal. But so far, I've found that it's very useful for students who want to move faster than the class. Anytime you've got a group of students with a mixed background, you know, worry about the slow students in one area, you worry about the fast students in another. This gives the students a chance to move quickly, to try things. The next item may even be more important. Students are driven to learn more so that they can get further in the puzzle. I had a number of students who, when they zipped through the basics and the assignment statements, they said, I need to know how to use if statements. Tell me how to use if statements. Having students pull you along and make you move, much more satisfying for everybody than trying to push the students along. I've also found that since the Code Hunt work isn't graded per se, I don't put it in the report card, I do allow them to do some work together. And I find they work very cooperatively, usually in pairs. I also find that students who figure things out are very interested, for all the competitive feature, you know, that they want to get things first. Once they've gotten things first, they're more than happy to bring their peers along. And the other thing I found from long experience is that Students listen better to each other than they do to me. Apparently, somebody who's never programmed before is a much better expert than someone who's been doing so for 40 years, you know, as long as they're 15. So, but that's okay. The other observation I've had is that the girls enjoy Code Hunt just as much as the boys. Again, that's observational. The end value is very low. You know, I come into class and several of the girls are running Code Hunt, and they're working on the puzzles, and they're working on it at home, and they're interested. You know, I have a theory about that. I don't have data, but again, I think most students, especially those who are shy or who feel intimidated by the environment, are less threatened by getting the answer wrong if only the computer sees it. So they're comfortable with that. They like points too. They like the satisfaction of solving the puzzle. You know, and I haven't seen, you know, I haven't seen a big gender difference. And again, it's gender equity is something that I'm very sensitive to. Having a wife who spent years working in the software industry, I saw a lot of things I didn't like to see, but we'll want to do that.
What percentage of women do you have in the class?
Great question. I'm running about 10%, which is, you know, obviously smaller than I'd like. We changed our first computer science course a year and a half ago. It's a course that 90% of our freshmen take. It originally was just Office, which is fine as far as it goes. We decided that students really should have learned most of that before they got to high school. So we created a one-semester broad breadth computer science class where we do spend about the last third of the semester doing some programming. We're hoping that over time, since about 90% of our freshmen take that class, that we're going to see more women take additional classes. It's something, you know, we encourage strongly, and we try very hard to keep an environment that's friendly to women. My most recent effort is I bought a poster with somebody did a Kickstarter program where they've got playing cards. We're on the faces of the playing cards are famous women in computing. So I bought the deck, but I bought a poster that has all 52 cards up, and I hung that right up in my room. And I mean, that's an example. It's not sufficient by itself, but again, it's part of creating an environment that's friendly to all. Try and you know, avoid the programmer environment that we hear about in a lot of places. And if Code Hunt turned off the girls, that would be a serious negative. So it's very encouraging that it doesn't. Again, and it's not just girls. I mean, there are boys who come into the class who are very intimidated. Especially they're intimidated by the students, usually boys who have previous programming experience. So making everybody feel comfortable is a serious goal of mine in the classroom. Students' reactions briefly. This couple of quotes. Can we have the final on Code Hunt? I had that from 3 students. I'm like, you're struggling to go through the open zone, but you want the exam in Code Hunt. You know, are we going to do more Code Hunt today? You know, I mean, that's the first question. Are we going to do Code Hunt today? No. Oh, a lot more fun than listening to me. That's another reason to figure out building it. One of the girls in my class is involved in our school's robotics team. Our robotics team, believe it or not, is something like 55% female. The guy who's the moderator, he has this basic policy. If somebody shows up and doesn't know what they want to do, he teaches them how to use the power tools. He doesn't care if it's a boy or girl, somebody's kid brother, kid sister. They come in, they learn how to use power tools. And so anyway, she's on the robotics team. So she went to him and said, teach me loops. I'm stuck in Code Hunt. I need to know how to do loops. Teach me how to do loops. I wish she'd come to me, but if she goes to somebody she's comfortable with, I'm happy. And again, as I said, the kids will. I've always had, teaching in a computer lab with high school kids, you always have the problem of some wise guy, and it is usually a guy, who comes in and starts playing some game on the computer and won't stop until you come over and tap him on the shoulder. Well, once I introduce Code Hunt, then I have to get them to shut down Code Hunt so we can have a lecture. It's an interesting problem to have. It's so basically, where I'm at is I'm still experimenting with it. I'm still figuring out how it works, what works, how to use it. My near-term plans are to continue building out the zone that I've got for my class, for my students. That's one thing I want. I want to have that sort of box that I control, that I know well, that I can use and understand the student experience. So that's one thing I want to do. I want to continue to make some office mixes for the students to use for review. I want to include Code Hunt puzzles in more of them. And I'm trying to figure out how I can use the data that I do have to better get a handle on what the students are knowing. Grades are something I have to give, I hate to give. I'm certainly more interested in how much the students know and how to help them know more. If I could give every student an A+, I'd be a happy man, and I'd have a class full of happy students. And if the data that I have, limited though it may be, I can use to do that, to understand where things are going, I see that as a huge positive. So at this point, I'm pretty excited about it. Students are motivated, I'm motivated, they seem to be learning, they're solving problems. One of the things that we're seeing at the high school level is students who get there and they're used to having all of their problems have step-by-step instructions. I assigned a programming project and one of the students said, "Mr. Thompson, it doesn't tell us how to do it." No, it doesn't. The object is for me to find out if you know how to do it, not for me to tell you how to do it. So, but I think Code Hunt is going to help me do some of that. I'll open it up for questions.
Thanks very much. We've got time for questions.
Yes.
So the last point that you make in terms of being given instructions on doing things, right? I mean, we observe that transition for undergrad student to grad students, right, in classes. But I think different country, different culture, education cultures also have played a role there. Like, for example, in China, typically, we just respect authoritative, right? Teacher, we just follow whatever was told, right?
Yes, yes.
So with this kind of suddenly, you have to figure out what it is, right? And
yes.
I don't know whether they would play a factor in the U.S. K to 12, right?
Yes, I think it's the difference.
A lot of these kind of exercises would encourage them to think in an open-ended way, right?
We have a lot of middle schools, pre-secondary schools where the atmosphere tends to be on building self-confidence, not always through accomplishment, but through succeeding by following instructions. And we do have students who just blindly follow the instructions. I wish it was because of respect, but I think it's often out of laziness. And that's a cultural difference. And I've talked to faculty from other countries. I had a friend of mine who was teaching computer science, and she's originally from India, And she got so fed up with dealing with American students, she moved back to India. Which was a very great disappointment because she's a wonderful person. There are people, and the school that I teach at attracts from many different feeding schools. So I see a difference very often between students coming from one school and another. From some schools, they expect the rote step-by-step instructions. From others, they're more used to problem solving and being creative. Some kids have to be encouraged to be creative. Some kids just do it because that's who they are, and some kids you'll walk through an exercise. In my exploratory course, I start introducing programming with touch develop, and we do some turtle graphics. And I see two kinds of students. I'll go through a step-by-step, and they'll draw a picture, and half the students will go on and they'll start trying things, and they'll get all kinds of interesting. And what happens if I add another loop or change this value? And other students will just sit there and, what do I do next? So it's pushing them off that. I mean, I personally see software as a creative art, as a very expressive type of thing. And helping students to see that is something that I try and do. And hopefully I can send students off to university who are more interested in being problem solving and creative than rote. Anything else?
Since you've listened to everything that's gone before here now, what would you see would be the differences, if any, between what you're doing and what's actually happening at universities? Or do you think it's just the same?
My perception is that at the university level, faculty are thinking a bit deeper about the kinds of projects, the code hunt puzzles they're creating. And I think at the university level, people are doing it, I hate to say this, perhaps more thoughtfully than what I'm doing. I'm kind of running things right now by the seat of my pants. I'm hoping once I get things settled, then I can focus on doing things more thoughtfully. Again, I think high school teachers in general tend to work more on anecdotal data than on solid, repeatable data. I think most university faculty have had a bit more experience in doing that kind of research, and I think that long term is very helpful. And I'm going on observation. As I've been here, my big thought has been that I need to gather more data about what's going on so that I can get a better objective view on what's working and what's not. So that alone has been very valuable for me to get that perspective. Yes, sir.
As a follow-up to the question, like how feasible it is, for example, for many of us, from university to have collaboration with you, to look at the data, to really have tool support, to explore some of the questions, especially I think at the K-12 high school level, right?
Yeah.
How to improve the process. I think there are different kinds of special cloud.
Yeah.
From like graduate software engineering or like intro programming.
Right. And that's certainly something I would be interested in doing myself. We don't have, in my opinion, we don't have enough research on how to teach software development or computer science. There's a lot more research on teaching of reading, teaching of math, teaching of physics than we have on computer science. And I think a lot of us, especially at the high school level, are doing it wrong. I just don't know what right is. And if data can help us do that, I think that would be outstanding. Again, it goes back to I'm trying by observation to find out what kinds of things, what are the mental blocks, what are the incorrect assumptions that students are coming in for, and I think there's a lot more research we can do in that area, which is, I think, very interesting.
You must have some observations on that too, Pelly.
So I don't specifically teach EPCS, so I don't really teach an environment where I can use Coding.
You teach touch develop, right?
Right now, I'm teaching Minecraft, which is using Python. That creates a whole lot of motivation.
Yeah, I mean, that the game aspect of Code Hunt is definitely, the kids do see it as a game, and
So we've done studies, and there was a clear in-room competition where they would shout their level at each other between the rows. And we tried to cheat, sneak and see what the other guys had done, and the whole class was stuck on one, and once one passed over, he quickly he had an edge. So the classroom could see very interesting dynamics, and the girls were into the win too. So it wasn't just the boys who wanted to.
So while we're in a public forum here, we can just ask our students, when you were working on Code Hunt, were you doing it completely on your own, or did you have other people around?
So actually, my fiancée supported me with coffee only.
Coffee only.
Yeah.
Oh, right. And Vincent?
I worked alone.
You worked alone, and Alexei?
Use search engine.
Hmm?
I use search engine.
Oh, you use search engines? Well, that's fair enough.
I mean, Imagine Cup is very different than school setting. Right?
Okay, that's a contest setting.
It's a contest setting, which is
Yeah.
worldwide, so you would expect
Yeah.
players.
And I think you'll see some differences in context in between contests and in class, and it'd be less cutthroat in class, I think, sometimes. Not completely lack of cutthroat, but
Well,
less.
also because you were not making it as the assignment or anything.
Yes.
So it was for drill and practice.
Yeah,
Yeah.
and it's, yeah.
Right, well, talking of coffee, let's go out, and then we're coming back at 4 o'clock for our panel wrap-up and calls to action. And talking of calls to action, if I could ask the speakers to perhaps send me slides or bring them to me, that would be awesome. Thank you.